Hello, we're back again with the PLC-Uno. The PLC-Uno is a campaign on Indiegogo. We've set out to manufacture the PLC-Uno in quantities, and we are asking for the help of the community to enable us to manufacture this in large quantities. The PLC-Uno is built around the Arduino. I have in my hand an Arduino Uno clone, and this is an Arduino Due. The Arduino Due is based on an Atmel ARM chip running at 84 megahertz, and the Arduino Uno is based on an Atmel Atmega 328P chip running at 16 megahertz. The PLC-Uno also runs at 16 megahertz. A lot of people sent me messages on Indiegogo and Twitter asking what this project is about. What is the PLC-Uno? Well, first of all, let me tell you, a PLC is a programmable logic controller. So a PLC consists of a set of inputs. In this case, we have 8 optically isolated inputs. There are a set of outputs. In this case, we have 6 electrically isolated relays. And the output of the relay is connected to various loads. The contacts of the relay are connected to one 220 volt induction motor, a 24 volt DC motor, a 220 volt 100 watt lamp. We also have on the input side, we have a light dependent resistor. We have a light dependent resistor which changes resistance with the light intensity. We also have a temperature switch. This temperature switch has been fashioned out of a fluorescent lamp starter. And we have an analog input to which we've connected the light dependent resistor, and we have an analog output which is swinging the voltage from 0 to 10 volts DC. You can see we've connected an LED to the output. The output is also connected to a digital storage oscilloscope. You can see on the x-axis each division is 5 seconds, and on the y-axis each division is 5 volts. I'm going to show you the function of a PLC. So we have inputs, we have logic manipulated by a processor and our program on the processor, and an output which actuates stuff in the real world. Now let's see. First we'll see the analog input. We have a light dependent resistor, and think of this as your porch light. Here's your porch light, and here's a sensor which is sensing the ambient light. So we're going to make it dark. We're approaching evening. We're going to make this dark. There you are. As it becomes darker than a certain intensity, the porch lights come on. And when it's morning, the porch lights go off. After that, I have a temperature switch here. I'm going to use a hot air gun to heat this temperature switch. When the temperature switch activates, you will see that fan coming on. There you are. The fan is switched on. Now I remove this hot air gun and the fan switches off. So that was a temperature sensor, a temperature switch, and when it got heated up, it started off a fan. Then I have a DC motor, a 12 volt DC motor. I put the switch on. The switch is sensed by the processor, and the processor then switches on an output, and that output switches on the motor. There you are. You can see the DC motor has started running, and the moment I leave this switch, it switches off. I also have a 220 volt induction motor. This is an AC induction motor. I press this switch and the 220 volt motor starts up. Now if I had a bare Arduino board, I would not be able to do all of this. I would not be able to switch on these loads. But because I have a PLC, all the output actuators and the input interfacing through optical isolators is already built in. So there's absolutely nothing more I require to do all of this or switch on any kind of load in the real world except for the PLC-Uno. The PLC-Uno is a community project and it is open hardware. I request the entire community to get together and help us manufacture the PLC-Uno. Please go to the Indiegogo site and look for the PLC-Uno. Thank you.